In this video, we're going to talk about inscribed angles and all of the theorems and postulates that go along with inscribed angles. So the very first theorem that we're going to look at is the measure of an inscribed angle is half the measure of its intercepted arc. So what does that mean? So let's say this is A, B, and C. So the measure of an inscribed angle. An inscribed angle is an angle that has a vertex on the circle and two endpoints on the circle. So angle A or BAC is an inscribed angle. So the measure of angle BAC is half the measure of the intercepted arc. Well, the intercepted arc is the arc between the two endpoints of my angle. So the intercepted arc would be the measure of arc BC. So if I know the measure of BC, let's just say BC was 50 degrees, then my intercepted arc is my inscribed angle is half of that, so it would be 25 degrees. Okay, so the next theorem is two inscribed angles that intersect the same arc are congruent. So we're going to keep this one right here so that we can look at it. Let's call this A, B, C, and D. And let's say arc AD has a measure of, let's just say, 130 degrees. Well, when I take a look at angle ABD, remember from the theorem above, ABD is half of the intercepted arc. So ABD must equal half of 130, so it's 65 degrees. But ACD is also an inscribed angle whose intercepted arc from A to D is 130, so it must also be 65 degrees. So I can say that these two inscribed angles, since they intercept the same arc, they are congruent. They're both 65 degrees. All right, so how about this next one? An angle inscribed in a semicircle is a right angle. Well, let's prove that that's true. All right, so the angle that's inscribed in the circle is this angle right here, and it is marked as a right angle. Let's call it ABC. The arc that it intercepts, right, here's your two endpoints, this arc that it intercepts right here, I'm going to draw it in red. Since this is a diameter going across, the measure of the degree of this arc is 180 degrees. Since the inscribed angle is half the measure of the intercepted arc, this must be 90 degrees, meaning it has to be a right angle. Okay, and then we're just going to take for face value here that opposite angles of a quadrilateral inscribed in a circle are supplementary. So let's just call this angle A, B, C, and D. Opposite angles, corner to corner, corner to corner. The measure of angle A plus the measure of angle C is 180 degrees. The measure of angle B plus the measure of angle D is also 180 degrees according to this theorem. And now the last theorem, it's the measure of an angle formed by a tangent, and here's your tangent right here. Your tangent is right here, okay? And a chord, your chord is right here, right? It connects 2 points on the outside of a circle. So this is your angle. This angle in red is formed by a tangent and a chord. It is half the intercepted arc. So if this is A and B, the intercepted arc is the arc that joins A and B that goes through this angle. So let's just say this is 200 degrees. Since it's half, this angle would be 100 degrees. Okay? All right, so let's go ahead and start working on some of the examples that will be on our worksheet. So we need to solve for any of our variables or any of the indicated angles. So it says, our theorem is the measure of an inscribed angle, and here's your inscribed angle, is half the measure of the intercepted arc. So if I draw the angle in color, okay, and here's the two ends of my angle, this is my intercepted arc. So x is half of that arc. X equals a half of the arc measure, which is 90 degrees. So x equals 45 degrees. Okay, so let's see what A is. Okay, here is my angle, and here is my intercepted arc. If I join the end points of my angle, right? If this is 90, 90 is half of the measure of my arc. So 90 equals half of A. So what is A going to be? Well, if I multiply both sides of this by 2, I get 180 degrees equals A. So that's the answer there. All right, so let's find out the measure of A and B. So I'm going to trace angle A first. Angle A is made up of these two chords, right? Here's the vertex of angle A. Here are the endpoints. So this is angle A's intercepted arc. Angle A is half. A is half the intercepted arc. So A is 41 degrees. What is angle B though? Well, I'll trace B. B has the same endpoints as A, so its arc is the same. So B is 1/2 of the arc, which is 41 degrees, which makes sense. They intercept the same arc. They should be congruent angles. Okay, let's see about this one. We have to find A, B, and C. Well, I know that this is a diameter, so half of my circle should add up to 180 degrees. So A degrees plus 95 degrees should equal 180 degrees. So when I subtract the 95, A degrees equals 85 degrees. And we won't say 80 degrees, we'll just say A. A equals 85 degrees. Well, now let's go ahead and trace angle B. It hits my circle here in these two spots. So the end points of my angles on the circle is that arc. So B is going to be half of 95 degrees. Half of 90 is 45, half of 5 is 2.5. So B is going to be 47.5 degrees. So now what is C going to be? Well, let's trace angle C. Angle C is this angle here, and it shares these endpoints. So this is the arc that it makes. I know that the green arc was 180 degrees. That means this yellow arc must be 180 degrees because this is a diameter. So C is half of 180 degrees. So C is going to be 90 degrees, which makes sense because it is inscribed in a semicircle. So it must be a right angle. Okay, so let's take a look at this example here. So angle C is this angle. And I know that the measure of angle C is half of its intercepted arc, which is this. But I don't know the measure of the intercepted arc. How could I find it? Well, I know the measures of all the arcs together all the way around the circle, right? This arc and this arc and then this arc should equal 360 degrees. So let's see, 60 degrees plus 90 degrees plus D degrees, that should be 360 degrees. So 150 degrees plus D degrees is 360 degrees. D degrees is 210 degrees. So D is 210. So my red arc is 210 degrees. So C is going to be half of my red arc. So C is going to be 105 degrees. All right, so how about this next one? This one looks interesting. Let's take a look at angle E first. I'm going to draw that one in green. All right, so its endpoints on the circle. This is the vertex, so we don't count that. But its endpoints on the circle gives me this arc. So E is going to be half the measure of its arc, which is 78 degrees. So that's going to be 39 degrees. So now let's go ahead and trace F. F looks like this. So its endpoints are here, so its arc is right here. So F is going to be 1/2 of its arc length. Its arc measure, I should say. So F is 15 degrees. All right, so we have actually a triangle here because D here, this angle and this angle are the same, so this is D in here. So if I draw my triangle out here, F was 15 degrees, E was 39 degrees, and this was D degrees here. I know in a triangle all my angles add up to 180, so I should have D plus 39 degrees plus 15 degrees is 180 degrees. D plus 54 degrees is 180 degrees. D is going to be 126 degrees. Okay, so I'm going to pause this here and I'm going to continue on the next video with the rest of the examples.